welcome back to the channel. So here we are discussing the question Hamon Odyssey. So the question states that Jonathan is fighting against Dio's vampire minions. There are n of them with strengths even to an. Denote L, R as the group consisting of vampires with indices from L to R. Jonathan realizes that strength of any such group in its weakest link, that is the bitwise AND, and more formally, the strength between L to R is defined as all elements from AL to AR with AND operation. So, because Jonathan would like to defeat the vampire minions fast, he will divide the vampire into contiguous groups such that each vampire is in exactly one group and sum of strength of group is minimized. Among all ways to divide the vampires, he would like to find out the way with the maximum number of groups. So we need the maximum number of groups among all possible ways to divide vampires with the smallest number of strengths. So let's see at the test cases first. So for first test case, we have n equal to 3 and the strengths are 1, 2 and 3 of each vampire. Now we want maximum number of groups with smallest number of strength. So the smallest number of strength is obviously 0 here. We take the AND of all these three elements and check that it is coming out to be 0. So the maximum group is 1 here. In the second case, we take 2, 3, 1, 5, 2. So we can divide it into two groups. 2, 3, 1 have 0 and 5, 2 is also 0. Now let's understand how to do it with code. In this case the output was 2. So first of all, we can see that the maximum possible value of AI is 10 to the power 9. So if an element can be maximum 10 to the power 9, so the maximum strength, let it denote by ms, the maximum strength which can be there would be till the time the element does not reach 10 to the power 9. So what we will do is we can initialize the maximum strength by 1 and then till we do not reach 10 to the power 9, we would multiply maximum strength by 2. So in this we would roughly reach 2 to the power 30 or so, and we would have a larger value which would be almost nearer to 10 to the power 9. Now when we get the maximum strength, let's calculate minimum strength from this only. So initially we can have minimum strength, I am denoting it by MIS. So initially minimum strength is maximum strength itself, and then we will perform the AND operation of the minimum strength with each element. Here I is from 0 to n because we are taking each element here. Next what we do is, now we can initialize another variable, suppose value. So our value is initially the maximum strength until our value is not equal to the minimum strength, what we do is we perform the operation value and a of I, and if this condition is not true, then we would simply increment our answer. So our answer plus 1 in its, if this condition is not true, and we would put value equal to the maximum strength again. Now lastly what we check is if the minimum value is greater than 0, then what we do is if minimum greater than 0, then we would add 1 to the answer. So it would be answer plus 1 here, and after this we simply return the answer. So the answer is returned.